and this is my talk about Python 2 Birds with One Stone, which this is me. I'm a hacker from Dallas, Texas. I kind of hate Python 2. It's wrecked entirely too many of my dev environments, and I've had to rebuild things over again, and I'm just tired of it. 3-time now Hack Your Derby first place finisher. I have entirely too many hobbies. I love Python 3. I wear and now make bow ties, and I love coffee. Seriously, I love coffee. I take a picture of every cup of espresso that I make at home, and this is a couple weeks, maybe 2 or 3. Python 2 is being deprecated on January 1st, 2020, which is going to be a fantastic day. It's literally one of the greatest days of my life, I think. But in reality, not a damn thing's going to change. When it comes down to it, Python 2, all of that code's still going to run. It's still going to have new projects even, partially because the last thing that's on here, your Mac's still going to ship with Python 2.7 on it by default, and they're just not fixing that. One of the other big issues with it is that you're not also really taught to use virtual environments, which is another problem with that on its own, because it's the best way to really make sure you're using the right version for things and not just using it across everything. But like it also says, Python 3 code is still going to be prettier because it's freaking gorgeous. But the big thing is that we can do better than that, than just continuing to use that code that was there from before and that is already something that's being written, or even that is sitting on our system that we're trying to work with. And it's like hackers, we have a real problem because we come in, especially if we're doing pen testing or any sort of reports on vulnerabilities, and we jump in a lot of cases, we have to go, hey, look, this is this deprecated code that you are using right here, or this deprecated software that you're using right here. You really shouldn't do that because it's no longer receiving some sort of update. It's no longer actually getting helped anymore. But by the way, ignore the fact that we found it with this code here that was an exploit DB that was running Python 2, which is going to be or is deprecated very soon. So we have this high level of hypocrisy that's going to be happening here very quickly, and we need to be able to do something about that. Inside of exploit DB, as of last night, or technically early this morning at some point, the total split here is it's about 21.3% Python 3 and everything else is Python 2. This is determined by the Python 2 to 3 tool and what things it says it needs to change versus what things it doesn't, as opposed to doing something which actually gets pretty close to this, and that's just searching for print and then a space. Which is good enough to find most things actually for Python 2. So how do we really get started to change all of this code over from 2 to Python 3? Use the Python 2 to 3 tool, but it doesn't do all of the work for us. And it breaks. That's really what's going on here, is that, as you can see, there's some parse errors in here where inside some of the code that we're going to look at in a minute here, you'll see where it hasn't been formatted to be an actual Python script inside of exploit DB. And so we're going to take a bit here to kind of look at some of the code that's happening. And we're going to walk through kind of what I've decided and how I'm doing things to help fix this. So this is one of the pieces of code that very obviously kind of breaks here. And the reason why is if you'll look at the very top here, you'll see that that's not valid commenting for Python. That's C style, and it's not going to work if you just decide to run this particular Python script. Which means that you're going to have to pull code out of it or pull it out and stick it into your interpreter and work off of that instead. And while sometimes that's helpful, it also is a break in your process. You should just be able to be inside of exploit DB, run searchploit, find the thing that you're looking for, and run that piece of code. It should then, give you kind of a help, give you some sort of information upon running it. You should never actually have to open this script. It's not great. But some of the other things that's going on here is it's using URLlib2, which is not safe and secure and doesn't really pop up in Python 3. It's got a hard-coded IP address that's in there, hard-coded password that you would be changing something to, and this really long string that just is way past the borders of your text editor or your IDE, whatever you're actually using. And this definitely is not PEP 8, which makes me sad. So with this, there is a little bit of structure to the code, though. You can see that we've got like a server IP address here is some sort of declaration that's happening, and it's putting a single value into it. Same thing with username, except it's really long, and then same thing with the password as well. And then we can also kind of see where the code's being used and how it's actually being adjusted, which means that we can kind of take all of that out and put it into its own class and build in something kind of pretty here. Where we've got an argument block that kind of says, hey, these are the arguments that we're interacting with. We have an execute that's actually like the main, and then we also have a help function that displays all of the nice, lovely either ASCII text or any credit or anything like that that goes towards the actual previous thing that we were working off of. So that way, one, we don't claim that we actually wrote the thing that we didn't write, and two, we get to still use it in a prettier manner. And what you can actually do is take that kind of nicely formatted class and build a command line tool to interact with all of them. So if they're all formatted in that same way, you can build something that automatically generates the argparse to actually take all of that code in and get to the point where you actually have something like this, where you could just run that. So like I said here, the kind of thing that's going on is we're using some argparse, some import lib, some well-formatted classes like I showed you there a second ago, and we're kind of abusing some of the Python imports and doing some dirty dictionary class magic. So this is the tool that I ran a second ago, the actual command line thing that picked up that script, pulled it out, and ran it. So it's very short. All it does is pull that class in, read inside the actual arguments that it's dealing with, and then start to process through it. And it just runs the execute command down at the bottom. And it's doing all of that just using the import library, using some of the stuff that's inside of there. And as we'll see here, the dirty class magic, or the dictionary magic is, I don't know if you can read that very bottom line of the exploit class definition there, or just above where it says exploit arguments, the self-dict update, and then it's taking the argparse module and shoving that in there. That actually lets you get to the point where you can do the things like the, we have a self.target in there. So that way we've taken that argparse value and just shoved it straight in there because we know that's going to be what it is anyway. So now we have this new class value instead of having to reference it through argparse or reference through some other object. We just have it straight into the class. So reformatting these modules like this, it's kind of a pain in the ass. It's really tedious to sit down and go module by module, fix all the errors that are in there, pick them up, put them where they're supposed to go, and then make sure all the comments and everything are doing what they're supposed to be doing. Getting it all there it sucks. It really helps out, though. That's one of the things that's useful about it, is that it takes some of this code that we've let sit there for a decade almost in some situation, or almost decades at this point. And we're bringing it back up into the future so that you don't have to use a bunch of different virtual environments just to be able to execute a single thing from ExploitDB. Which is, it's a great resource. Why are we letting it decay like that? And there is kind of a way to do this a little bit better, I found. Abstract syntax trees. Is anybody here familiar? Or do we have anybody that? Awesome, we've got a few people. Have you guys used the actual AST module inside of Python, or are you using something else? Okay. Well, an abstract syntax tree is kind of a breakdown version of the code that you're really looking at. And it takes the structure of the code and it takes the elements of the code and puts it into a nice, lovely object that you can interact with. Like it says here, the code, you or somebody on Stack Exchange wrote it, you should definitely know what's going on there. The scanner, it kind of scans through the entire file that you've got, or whatever source block you give it, and it separates it out into individual blocks. Most of the time, this is based just on spaces in between things, and it just says, okay, these are what you're looking at, this is everything that's going on. Then you have a tokenizer and a lexer that goes through everything, and it pulls out all of those individual things and links them together, so instead of seeing, you know, a double quote and then a few words, or a word, and then another double quote. It puts it all together and says, hey, this is a string. This is what you're actually interacting with here. And then the parser kind of takes all that information, looks back at the original code, and builds this syntax tree or this parse tree. And if you look at the actual AST module inside of Python, you'll find two things. One, it's very, very loud in what it does. Like it creates a lot of objects in there. But that's the good thing, because it actually helps you have a special, unique way that you can work through all of the interactions that are happening. And with that, you've got a bunch of things. You can see here, it's like this body that's happening inside this module. It's got this special out, hey, this is an import that we know is happening here. And we know that this import calls this module Phyto.basic. And we also know that, it's pulling out the exploit from that. Inside of all of that, it's breaking all that stuff down into little blocks and putting it so that you can actually interact with this code. So what happens with second thing on it, ASTs are actually horribly documented inside the base Python documentation. Don't go to the actual Python docs. Go to this website at the bottom here, greentreestakes.readthedocs instead. It will tell you everything you actually need to know about interacting with ASTs and give you a pretty cool tool to kind of print them out, like this one here, which doesn't happen inside of the actual thing. So you have to decode some things differently. But if you want to actually interact with them, you can build these different transformers and viewers, or visitors, I guess is technically the term. But you can set up, like, for example, one of the things that I did inside of this was look for the if name equals the main thing that you always see at the bottom of code, so that people just run whatever function or run their actual main from their code. This is the code to actually identify that and kind of replace it and pull that code out of it so that we can stick it back into a main later on, or into our own function later on. Sometimes it gets a little crazy because the way that the ASTs interact, they're really harsh about all of the data that's inside of them. So you kind of have to do a lot of type checking as you go through things. There are other modules that do this a little bit better, like the Red Baron module, for example, does this pretty much better than this. But I liked the default AST module, so that's what I'm sticking with here. We're going to look at some of this code and some of the transforms that's actually happening from some of the code that I wrote for this specific situation, because I got tired of doing all of these transformations by hand. We have like a huge commented code block at the top. Then we have a couple of variables that end up being created, and then it's doing some things. What we can do is use some abstract syntax trees in the AST module to actually run through that code, read it, and create this automatically. Just generate this for every file that it can run through. And this is the exact same kind of class setup that we were looking at before, except the return for the local arguments is a little more spaced out because I auto-pep-aided it, and it didn't like that. But it still gets you all that information in the spots where it needs to go. Our execute's even just the exact same thing that was inside of the main just a second ago. We just stripped it out and put it where we want it instead. We also, in the cases of where we had any of their variables from before, we took the names from their variables, tacked the word self in front of them, and we operate off of it from there. And then, as it says at the bottom, the totally stolen code with no credit, because I haven't quite got the commenting part done yet, because that actually, ASTs don't deal with that part of the code. You have to actually interact with that at the lexing point, and I just haven't gotten to that yet. So what can we kind of do to write some prettier Python here? We can use more classes in our code. That's one of the things that I found from ExploitDB in particular. It has a lot of really bad variable names. They're all A or B or I. I is good for an iterator, end of list. Don't use it otherwise. Target is probably the best variable name that I think I found. Yeah. So say what your variable names actually are. If it's, some sort of handle to a class, make it exploit handle. Like, that's a good way to know, hey, I'm interacting with an exploit. I know that's what this variable is going to be. especially since Python's really loose on its class and typing, you can help build some of that in with your actual code so that you know what's happening as you're writing it. Use an IDE. Obviously, I love PyCharm. That's what I've been using for all of this stuff here. And then also PEP8. PEP8 is a great structured way to organize all of the losing all the lights there. Do I need to move? Okay, no. Yeah, it's okay. Everybody can fall asleep and then we lose the lights. It happens. But so yeah, PEP8 does a great job of giving you a way to organize your code and code to that. I think it's fantastic.
Light switch red.
Yeah, we're gonna be okay. The cheat is totally fired. Yeah, grounded. So, we're gonna take a break from our slide deck here real quick. But not everything else, hold on. Let's see. I'll get this stuff moved over in just a second. It's just a gigantic PyCharm window. All right. Awesome. So what's going on here, let me get this other one over here too, is we're going to do a little bit of combination Q&A and look at this thing actually work. So we're going to run this, and it's just doing its thing right now. That's all it's kind of doing. And as you can see there, it kind of just jumped up a bunch of modules that it decided to go ahead and go with. And that's what it's really kind of working on here, is it's just converting these modules over as it sees them inside of ExploitDB. It's searching through all the ones that are in there. It's pulling out all of the modules that it can actually deal with that are from Python 2 to 3 that I had to do beforehand, because that was actually taking about 12 hours to really get through all of it, and it still wasn't finishing all of it, because some of the, at least if you run 2 to 3 at the whole repo all at once on an old school laptop, it doesn't like that. So you do what you can. But what we can do is kind of take a look at some of these. Some of them are going to be blank. Some of them are going to be a little bit more broken here. But as we can see, it straight out generated this code. In this case, they actually were, they had this string inside of their main, so it ends up still inside of here. And so you get to keep some of the cool ASCII art, which is one of my favorite things about that, is I want to keep the ASCII art because it's so badass. And then eventually we'll actually get to some code. This is one of the worst ones because it's just a lot of that. And then hey, here we go. See, they even like the ASCII art inside of their actual code. But it works through this whole thing and does what it's supposed to do off of that. And let's see, how many of these are we up to here? Can anybody actually read that number? Because I can't.
14, 13.
Okay, that's about where it's going to actually crap out at this point, because let's get back over to our slides here. Let it keep running. But it's at the point where it's doing a lot of this conversion, and it's still getting a lot of this done for us, but it's also kind of breaking in cases because I don't have something set up for every single individual thing that it's actually looking for. The biggest case in point for that is I was going through this and I'm like, I'm gonna find these individual variables and I'm gonna work off of those, and then I realized shortly afterwards that, oh, I could steal the stuff from argparse. That's a good idea. And so I started doing that. I took all their stuff from their argparse and converted it over back to my format and then stuck it in there and replaced all of their variables so it's not using like the whatever parser they set up dot thing anymore. And then about 26 or so hours ago, I realized, oh, people still use the sysargv thing, and that's going to literally break all of this. And it is actually literally breaking my code that's meant to actually find the argsysv, or the sysargv stuff, because it's just not done and fully debugged yet. But once that happens, I have a feeling that's going to add a lot more of these modules that are actually going to be successful. Out of the I believe it's close to 2,900 modules that are in ExploitDB that are in Python. We get about half of them that are actually parsing through all of this. And as I work through it, there's just going to be more of these that end up getting done. Whenever I actually put in for this talk, I promised that 50 of them were going to get it done. I think like 1,400 minus I think it's close to about a 10% error rate is slightly over that. But my next steps on this are I'm going to kind of take a short break because I redid this entire code base starting on Tuesday because that's when I decided, oh, I can do this way instead. And I'm exhausted. So fixing the argv issues is one of the things I'm going to do. Fixing the Scapy import all kind of thing for all sorts of different modules that you see, Python modules, not ExploitDB modules. That I think is one of the worst things that you can actually do in Python is import all of a class like that, especially down to your base level. You don't know where anything is coming from. It's really hard to root through and fix anything afterwards, and stuff just kind of magically feels like it's actually in Python that's not in Python anymore. And so if you try to change back to anything else or try to change your code at all, it just destroys everything that's going on. So please stop doing that. And if you're somebody that's from a project like Scapy, please stop making your project require that or that the default tools tell you to do that. It'll make everybody happier. Obviously, that's a large nitpick, but I have a few others that I actually want to adjust through as well. And obviously, like it says at the bottom, work through some of the bugs to help fix some of that plus or minus 10% that's kind of breaking inside of the code. So earlier, I mentioned the class dictionaries. You can have a lot of fun with class dictionaries. You can straight add things so that your class all of a sudden has its own variable to it. It has its own function to it. It has a lot of different things to it. You can even, in a goofy way, take your class and give it a new variable name, so dot function or dot whatever you want to call it, and have that value be a lambda inside of the dictionary so that you've actually just created like this kind of YOLO function inside of your class. It's not always useful, but if you're doing something like building a web API off of a WSDL, it's actually pretty decent for that because you just get to build like the one interaction, especially RESTful interfaces, which are, oh, I love them, so much better than SOAP. But they help get you through doing cool things like that. There's little tips and tricks and goofy things that happen with it though, so don't cry whenever it ends up being the same thing for all of them. So if anybody wants to actually help me out here, this Phyto repo is the one that's actually the end result. That's where the successfully converted modules are going to go. The one that's below that is the actual converter itself, and it's the big thing that I've been working on to make this happen. And it's the one where I need to see like bug reports. If you go through and you look inside the Phyto repo and you're like, oh, there's these 15 different modules that I'm seeing that are all breaking in this exact same spot. That's where I need to know about that so that I can actually jump in and fix it. Or if you want to please send your own pull request to fix it, that'd be fantastic too. If you want to contact me, Integral at Twitter, also at the Gmails. Does anybody have any questions or comments or anything like that? Just about at time? Awesome. Hold on, let me show you something then, if we got a second. I can show you this code that I'm way more proud of than I should be. Let's see here. So this is kind of an example of exactly what I was talking about, which we can't see at all because, yeah, hold on. Try to help us out. So the aspect ratio changes a lot going over there. So kind of what we're looking for is yeah, so this thing right here where we're going in and we're jumping into the request and actually giving it a lambda that it actually interacts with instead of giving it functions. This ends up taking the entire Hashtopolis API, which is something like 10 LaTeX files that they have sitting around, and it reads through all those LaTeX files and builds an actual API for the whole class, so that you can then hit it up and go, hey, users dot this other thing dot this other thing dot get hash things, and it'll actually pull that stuff out from there, and it's all generated from their code as opposed to actually having to write the 800 lines of Python or so that EvilMog had written before. So that's my time. Thank you, everybody. I appreciate it, especially showing up so early.